Okay, today we are going to try this 10-year series question. Okay, it's about HCF and LCM. So here we are trying to find two numbers, both smaller than 100. Okay, the only condition that they give you is the LCM is 450 and the HCF is 15. Okay, now before you do this question, first of all you must understand how we find LCM and HCF from two numbers. Okay, so before we do this question, I'm going to give you a very simple example over here. So for example, if the first number is say let's start with 45, and the other number is say 21. Okay, right. So what we're going to do is we're going to take this 45, we're going to break it up into prime factors, which is 5 times 3 times 3. Okay, and 21 will simply just be 3 times 7. Okay, do note that all these numbers must be prime. Now, once this is done, to find the HCF, we just circle those that are common. Okay, so there's nothing else that's common, so the HCF is just 3. Okay, now if there are other numbers, like for example, if this number here had a 7, then we need to circle the 7 and this 7, so the HCF will become 21. Okay, now what about the LCM? Now for the LCM, we will simply just take the maximum. So here for the 3, there's one 3, but here there's 2, 3 square, right? So the LCM will be 3 square. There's a 5 here, so we raise to 5. There's a 7, so it becomes 7. Okay, so the LCM will be 45 times 7. Okay, so 45 times 7, it should give you a 315. Okay, so that's the LCM. Okay, so for HCF, we circle those that are common. For LCM, we will take the maximum out of every number from here, the maximum possible from every number. Okay, so you have to know this number. Now how do we come back to this question now? Now for this question, first of all, let's try to find, so we are trying to find two numbers. Okay, so the first number is A, let's call it A. The second number is B. We are trying to find these two numbers. These numbers must be smaller than 100. Now, first of all, let's try to find this LCM. Okay, LCM for 550. Now, if you take this 450 and you break it up, you do the prime factorization of 450, you're going to get 2 times 5 times 5 times 3 times 3. Okay, so that's the LCM. Okay, now the HCF is 15. Okay, it's a 3 times 5, it's just 15. That's the HCF, right? Now did you notice that for the HCF to be 3, do you notice that both of them has the HCF inside? It is confirmed. So with these two numbers, if I tell that the HCF is 15, I can confirm, be very sure that both of them must have 15 inside. But of course, there are other numbers, right? Both of them have other numbers. Okay? So let's go. So let's start our progress. Now, in order to make sure that our LCM has... Okay, so what are the numbers that are not done? So we have input a 5. We have input a 3. What are the numbers that must go in? These are the numbers here. This one, and this one. They must go into places here. They must either go here or here. Okay, all these numbers. Okay, as we are trying to fill in the numbers, one thing we need to take note is both numbers cannot exceed 100. Okay, they cannot exceed 100. So let's try. Okay, let's try to put a 2. Okay, let's try. Let's put a 2 here. Now, if we put a 2 here, then it works, right? So 15 times 2 is 30. Okay, that works. Now let's try to put the next number, 5. Let's try to put maybe can we put a 5 here? Now I can try to put a 5 here, but in this case, then it will be 10 times 15. 10 times 15 is 150. It already exceeds the 100 here. Okay, so 5 cannot be here because 5 is really big. Okay, 5 is really big. Now what about this 3? Can we put a 3 here? Okay, looks like it, right? Looks like it. Can we put a 5 here? Cannot, because it will be too big. So the only way that this 5 can go is here. Alright? So it will be 2 times 3. This 2 and this 3 goes here. The 5 will be alone. Alright? So let's check the numbers. What are the numbers? It will be 6 times 15. 6 times 15 is... how much? 6 times 15 is 90. Okay? So the first number happens to be 90. The second number is 15 times 5, 75. Okay, so these happen to be my trial numbers. Do they work? Now let's see. Let's try to circle the HCF. So the HCF is 3 and 5. There's nothing here we can circle. So the HCF is verified, is checked. Let's try the LCM. Okay, so LCM, first we have a 2. Okay, for the 5, there's 1 here, there's 2 here. So we have to circle both of them. 3, there's 1 here, but there's 2 here. So we circle both. LCM checked. So the numbers is 90 and 75. Okay? So that's the first 10-year series question. Okay? Now we're going to pause for a while. Okay, you can pause the video here for a while. I have another question that is similar, contributed by one of the students from P44. Okay, I'm going to remove this first question. Alright, the second question is this. Very similar question. Very, very, very similar question. So here they say that there are 2 numbers. As usual, there are 2 numbers. They first say that the LCM is 4860. The HCF is 405. Okay, and both numbers must be greater than 405. Okay, let me zoom out. Let me zoom this out for a while so that I have more writing space later. Okay. Oh, sorry. Okay. Right. Okay, so let's begin. 4860. Of course, we must prime factorize these 2 numbers first. That's our very first step. Okay. So let's try. 4860. Okay, so let's prime factorize this. 4860 is actually 2 square times 5 times 3 to the power 5. We're also going to prime factorize the 405. Okay, so when you prime factorize 405, it's actually 5 times 3 to the power of 4. Okay, so you cannot get this wrong. Now, let's start the process. We have to find the 2 numbers. Okay, let's call our first number A. The second number we call it B. Okay, now this is the HCF. This is the HCF. Alright, so let's write down here. This is the HCF. This is the LCM. Now just recall that just now when we actually tried to find the HCF, the first thing is the HCF is something that is common in both numbers, right? It's not called common factor if it's not going to be a factor in both numbers, right? It's called the highest common factor, okay? It's common for both, all right? So both of them must have this, okay? It is fixed, okay? So that's the first step. You go. Now, as you compare the HCF and the LCM, okay, let's break down the LCM. Now, this is the LCM. The LCM is 2 square. There's a 5. There's a 3, about 5. Now, if you compare them, you will notice that what we need to compensate over here in these numbers here is simply just a 2 square. This is missing. Here they have a 3 to the power of 4, but we need to raise this up to 3 to the power of 5. So we have 1 3 that is unaccounted for. Okay? Right. So let's go. How do we put this in? Right? Now, this is 405, right? So let's try to put some numbers in. Can we put a 3 here? And maybe put a 2 and 2. Okay, so both numbers are greater than 405. Okay, so this is a bit of trial and error. Okay, both numbers must be greater than 405. So let's check. LCM, okay. Sorry, the HCF, okay. You circle the 5. You circle this. There's nothing in common here. Right? So this is the answer. Now, why can't we, someone was asking me, why can't we put a 2 here? Why can't we put a 2 here? You said that we need to compensate a 2, 2 and 3, right? Why can't I put a 2 here? Now, if you put a 2 here, that means this is common. The HCF will be 5, 3 to the power of 4, and a 2. But our HCF is only 5 times 3 to the power of 4. So which means this 2 cannot be on different numbers, because if you're on different numbers, you will have to circle both of them. So this 2 must be together on one side. If they are together on one side, there's no way you can circle. The HCF will still remain as this one. Okay? So if you have done this correctly and you do the necessary check, okay, then you will go and get the answer. So this is 405 times 3. Sorry, need to work out. 405 times 3, 15, 2. So it give you 1215. So that's the first answer. 405 times 4, that's 20, that's 16. So the answer is 1620. Okay? I hope that everyone have a very good time. Okay? You can pause the video, do the question yourself, and fully make sure that you understand. In a nutshell, you have to remember that HCF is something that you circle, that is common. LCM is you take the biggest factor from each of the numbers. Okay. Good luck for your O-levels.